organizing and displaying data. In order to make sense of it, we need to be able to see a graphical display of the data. So we're going to just look at one example here. Here's a set of data. It's out of context. It's just example. So let's say we have 90, 85, 88, 95, 100, 77, 85. These look like test scores, test percentages, 80, 77, 90. But we're just going to look at how to graph this and look at it. So the first tip, so all of our examples will be based on this data. And the first tip is when you're looking at that and it's not even in order, it's very hard to make any sense of it at all. So the first thing is put your data in order. Even when you copy it down, when you're given, put in order. Okay, so let's do that so we can start to see this. So the lowest, that tells us the lowest scores are in the 70s. So 77, 77, 80, 85, 85, 88, 90, 90, getting better, 95, 100, and 100, 100, and 100. Okay, so already that looks like we could tell like how many C's, B's, A's there were. Okay, so let's see here. The first type of way of looking at this is called a dot plot or a line plot. This is probably the most basic way of displaying data. It's called a line plot. It's easy to do by hand. Line plot or dot plot. And so you just make a number line, and you label it with values that are reasonable. Since the lowest is 77 and the highest is 100, I'm just going to go from 75 to 100, and I'll just go by something reasonable like by fives. So 75, 80, 85, 90, 95, 100, and I'm going to make sure they're equally spaced. And then you want a different way of looking at this data, so you put a dot wherever you have a data point, a dot or an X. So we have two 77s, so I'd go like that, two of those. I've got 180, so I put an X there. I've got two 85s. I've got an 88, which is 85, 86 is roughly here, doesn't matter exactly. A 90. I've got two. Do I have two 90s? Yes, two 90s. 95 and two 100s. Okay. So this is actually a way of looking at it, and it's a distribution. So you can see how many of each thing you have, and that word distribution is going to come up a lot, and it lets you visually kind of see what the data looks like. So that's one way. Now we have something called stem and leaf plot. Stem and leaf plot that lets us see it graphically as well. Stem and leaf plot. So here the stems are going to be the tens place. So like 70, 80, 90, 100. So you go like this. All the stems go on the left. So it's just another way of organizing your data. Let's say it's all out of order and you want to put it in order. This is a nice way to start. 7, 8, 9, 10, and then the leaves are the units. So we have two 77s. So you just write 7, 7 for the 77s. We have an 80, so you just put a 0. That represents the number 80. Two 85s. So you go in order. So there's two 85s. There's an 88, there's two 90s and a 95, and there's two 100s, so you put a 0 and a 0. And that kind of lets you see the distribution. It's just in a different orientation. You can see, for example, which one has the most test scores? The 80s, right? You can just see that visually right away. So, and then with a stem and leaf plot, it's important to always put a little key. So you get to pick any value you want and describe it, so just so that it's really clear that that means the number 77. You just pick any one number and you make a key for it. And that has to go along with your stem and leaf plot. Okay, and now moving right along, we have a histogram. Really important, you see these a lot. Histogram. And so what you do to make a histogram, it's like a bar chart, but technically a bar chart is for a different kind of data, and a histogram is for numerical data. So don't confuse those. Histogram, first you make a frequency table, and then we'll be able to make the bars. There are bars in a histogram. First make a frequency table. A frequency table is a way of looking at a distribution. How many of each do you have? So we'll make categories for our scores and then the frequency that we see it, frequency. And then we'll make a little histogram. So you can choose what range to use here, and there's ways to select, to make better selections, and you'll figure it out with practice. But I'm going to use 71 to 80, 81 to 90, and 91 to 100 for my score ranges. And so how many scores are between 71 and 80? Good. Is that right? 71 and 80? Including 80? There's 3? Uh-huh. And how frequent is 81 to 90? And how frequent is 91 to 100? Uh-huh. Great. So we're ready to make a histogram. So you have to label your axes, okay? And on the y-axis is your frequency. So you have to say that. On the y-axis is the frequency, and the values go from 3 to 5. I'm going to start at 0. So I'll go 0, 1, 2, 3, 4, 5. It makes sense to label every one. 0, 1, 2, 3, 4, 5. And then your histogram, it doesn't matter where it starts, but what is important is that each bar is the same distance. So from 71 to 80, from 71 to 80, we'll go up to 3. So here's my bar. And they have to be, again, there shouldn't be spaces in between the bars. From 81 to 90, we go up to 5. And these should be equal width. Otherwise, what might be the problem if I don't make them equal width? What might be the problem if these were different widths? So it might not accurately, it might look like the range is wider, right? When really they're all the same range. So it's important that you make, these should always be equally spaced. You choose equal increments for a histogram, and there shouldn't be any space in between them. So that's histogram, and the last one is our box and whisker plot. And this gives you a different look at the data. So so let's do box and whisker plot last, and I'll rewrite the data. This is this can be very simple, but let's see here, box and whisker. Feel free to actually draw whiskers for fun if you want. This is also known as, you'll hear it box and whisker plot or just box plot. Okay, so this, and there's some new terminology when we do this, box and whisker plot. So the goal is, it's basically all you're doing is dividing the data into quarters. How many quarters are there? How many quarters of a whole are there? How many quarters in the Super Bowl are there? 4. And so basically you're segmenting your data into the first quarter, second quarter, third, and fourth in order. And the way you do that, divide data into quarters, when you see the word quartiles, that's all it means, is quarters, quartiles. So let me rewrite the data in order, and I'll show you how to do this. It can be really simple. 77, 77, you definitely want your data in order. All we're going to do, let me rewrite this, 80, 85, 85, 88. What numerical value, 90, 90, 95, and I'm running out of space. Yes, okay. What numerical value do you know that puts something into half of it? Like what measure of center have we been using that splits it in half? Very good, the median. So all you do is do the median. So where's the median? Here? How many numbers do we have, and where's the middle? 88 is the middle, because I think there's 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No, there's 11 numbers. So we want 5 to the left, 5 to the right. This is the median. And that's Q2. And then we need Q1 and Q3. So now you just look at the left half to the median. Don't look at this number, look at all these and find the median again, because that would be the other quarter to divide it into half. So where's the half at? Good. So 80 is called Q1, or the lower quartile. And so you'll see this in your book, lower quartile, Q1, and where's Q3? 95, exactly. So to make a box and whisker plot, you have to do the median 3 times, and that gives you Q1, Q2, and Q3. This is called the upper quartile, And now we can make our box and whisker plot, and we will in just a second, but no, we're going to do it right now. So you do a number line, and this will be given on the worksheet. If not, you have to make one. So just make an equally spaced number line, just like we did in the very beginning. So from like 75 to 100, just choose something as long as it's equally spaced and reasonable. This is subject to interpretation of what values you use, what increments you use. That's just a number line. That's it. Now I'm going to make my box and whisker plot. So this is what you do. You just take the 88, you put a line wherever roughly 88 is. So I'm going to say there. That's Q2. You put a line where Q3 is, 95, and you put a line where Q1 is at 80, and then you make a box like that. And that box represents the middle 50% of your data. So half of your data, the middle half of your data is in here. And that it helps you visually see where's the middle half of your data. And then you take the highest number, 100. These are where the whiskers come in. The highest number, 100, and the lowest number is 77 in your data set. You put lines there, and then your whiskers just go out to those places. And then if you want to be cute, you can actually draw whiskers, but you don't have to. And that's not really how they work. But you could think that in your head as you make your box and whisker plot, or box plot. The last thing I have to say for terminology is this range is called the inner quartile range. It's a really important number in statistics. It's I'll write out the words for it. Inner quartile range. And how would you find that? You would that number is Q3 minus Q1. You just literally take those values and you subtract. So Q3 was 95, Q1 was 80, so the inner quartile range is 15. So that means that the middle 50% of our data, the middle half of our data it varies by 15. The range of the middle part of the data is 15. And this will help us determine our outliers. In the future, if we want to know, right now we're just like, oh, that looks like an outlier. It looks really big or small, right? But the real definition is if it's 15 bigger than Q3 or 15 smaller than Q1, then by definition mathematically it's an outlier. So that this interquartile range helps us determine if something mathematically really is an outlier or not.